The United States military just successfully tested a missile that travels at nearly 3,836 miles per hour while maneuvering unpredictably through the atmosphere. American soldiers are already using augmented reality headsets that let them see through walls and around corners. Quantum computers are being developed that could crack any encryption in just seconds. These aren't distant dreams, they're operational realities transforming how America fights wars. Welcome to the cutting edge of military innovation, where science fiction becomes battlefield fact, and tomorrow's conflicts will be won by technologies that seem impossible today. Hypersonic weapons, the unstoppable strike. A weapon that can travel from New York to Los Angeles in under 30 minutes while changing course mid-flight to avoid any defense system. This isn't theoretical anymore. The United States Army's long-range hypersonic weapon, nicknamed Dark Eagle, has successfully completed end-to-end flight tests and represents America's entry into the hypersonic arms race. The Dark Eagle system consists of a massive rocket booster carrying the common hypersonic glide body, which separates at high altitude and glides toward its target at speeds exceeding Mach 5. Unlike ballistic missiles that follow predictable arcs, hypersonic weapons can maneuver throughout their flight path, making them virtually impossible to intercept with current defense systems. What makes hypersonic weapons revolutionary is their combination of speed and unpredictability. Traditional ballistic missiles give defenders time to react and follow known trajectories. Hypersonic glide vehicles can change direction, altitude, and speed while maintaining velocities that compress reaction times to mere minutes. This capability allows them to defeat anti-access and area denial systems that would stop conventional weapons. The Army plans to deploy Dark Eagle in 8 missile batteries, with each M983 truck carrying 2 missiles in launch canisters. The first operational unit at Joint Base Lewis-McChord is expected to receive live rounds by May 2025, marking America's transition from hypersonic testing to operational deployment. The Navy's variant will equip Zumwalt-class destroyers and Virginia-class submarines, extending hypersonic strike capability across all domains. Directed energy weapons, the speed of light arsenal. Directed energy weapons, the speed of light arsenal. Imagine destroying incoming missiles, disabling enemy electronics, and neutralizing threats using nothing but focused light beams that travel at 186,000 miles per second. Directed energy weapons have moved from science fiction to battlefield reality, with the United States military deploying its first operational laser system aboard the USS Ponce in 2014. High-energy laser systems offer unprecedented advantages over conventional weapons. They provide virtually unlimited ammunition as long as power is available, eliminate logistical supply chains for projectiles, and deliver precise effects at the speed of light. Modern systems can engage multiple targets simultaneously while operating silently and invisibly outside the visible spectrum. The military has developed 2 primary categories of directed energy weapons: high-energy lasers for destroying physical targets and high-powered microwave systems for disabling electronics. Laser weapons excel at counter-drone operations, short-range air defense, and precision strikes against rockets and artillery. Microwave weapons can disable entire electronic systems without causing permanent damage to infrastructure. Current operational systems include truck-mounted laser platforms capable of destroying unmanned aerial vehicles and small boats. The Army's high-energy laser scaling initiative aims to develop more powerful systems capable of engaging larger threats like aircraft and missiles. These weapons represent a fundamental shift in military capability, providing commanders with precise, scalable effects that can be tailored to specific threats. The cost-effectiveness of directed energy weapons becomes apparent in sustained operations. While each laser shot costs only dollars in electricity, conventional interceptor missiles cost hundreds of thousands of dollars each. This economic advantage makes directed energy systems ideal for defending against swarm attacks and asymmetric threats. Autonomous combat vehicles, the robotic battlefield. Autonomous combat vehicles, the robotic battlefield. The United States military is developing unmanned ground vehicles that can navigate complex terrain, identify targets, and engage enemies without human intervention. But recent setbacks have forced a complete rethinking of autonomous warfare. The Army's Robotic Combat Vehicle program, launched in 2019, initially planned 3 variants but has been restructured due to evolving battlefield realities. The original RCV program envisioned light reconnaissance vehicles, medium support platforms, and heavy combat variants equipped with advanced sensors and weapon systems. These vehicles would operate alongside human soldiers, providing fire support and reducing risk to personnel. However, the war in Ukraine revealed critical vulnerabilities in slow, expensive robotic platforms targeted by cheap explosive drones. Current autonomous vehicle development focuses on practical applications rather than science fiction concepts. The ground vehicle. Autonomous Pathways project partners with commercial companies to adapt civilian self-driving technology for military use. Companies like Forterra, Kodiak Robotics, and Overland AI are developing navigation software that can handle diverse military environments. The shift toward practical autonomy emphasizes logistics and support roles over direct combat. Autonomous vehicles excel at supply missions, casualty evacuation, and reconnaissance operations where their ability to operate in dangerous environments without risking human lives provides clear advantages. These platforms can work continuously without fatigue and maintain operations in contaminated or hostile areas. Modern autonomous combat vehicles integrate artificial intelligence for navigation, obstacle avoidance, and mission planning. They can operate in GPS-denied environments using computer vision and terrain mapping while maintaining communication with human operators who retain ultimate authority over weapon systems. This human-machine teaming approach balances autonomous capability with human judgment. Advanced cyber warfare capabilities, the digital battle space. The U.S. military fights wars in a domain that didn't even exist 50 years ago, cyberspace. Here, battles are won with code instead of bullets, and entire enemy networks can be destroyed without ever firing a shot. U.S. Cyber Command has evolved into a unified combatant command, with 147 specialized teams conducting offensive and defensive operations around the globe. Cyber warfare capabilities now go way beyond traditional hacking. The military's cyber mission force includes teams that defend Department of Defense networks, protect critical infrastructure, and conduct offensive operations against adversary systems. These cyber warriors can disable enemy communications, manipulate enemy sensors, and, even cause physical damage to infrastructure through digital attacks. The Army's cyber units actually deploy expeditionary cyber and electromagnetic warfare teams to support tactical operations. These teams provide offensive cyber capabilities, information operations, and electromagnetic warfare support directly to combat units. They can jam enemy communications, intercept digital intelligence, and conduct cyber attacks that complement kinetic operations. Advanced cyber capabilities include artificial intelligence-powered threat detection, quantum-resistant encryption systems, and automated response mechanisms. The military is developing systems that can identify and counter cyber attacks in milliseconds, way faster than any human operator could respond. These systems use machine learning to recognize attack patterns and adapt defenses in real time. The integration of cyber operations with traditional warfare creates all new strategic possibilities. Cyber attacks can disable enemy air defenses before kinetic strikes, manipulate enemy logistics systems, and create confusion in enemy command structures. This multi-domain approach treats cyberspace as a maneuver space equal to land, sea, air, and space. Next-generation stealth aircraft, the Invisible Armada. The U.S. Air Force has confirmed the development of the F-47, a sixth-generation fighter that, honestly, makes the F-22 Raptor look like yesterday's technology. This revolutionary aircraft combines stealth capabilities that surpass current fighters with artificial intelligence systems that can command fleets of autonomous drones in combat. The F-47 represents the next-generation air dominance program's vision for the future of air warfare. Unlike previous fighters designed mainly for air-to-air combat, the F-47 integrates multiple mission capabilities including air superiority, ground attack, electronic warfare, and drone command. Its advanced stealth design potentially uses a tailless flying wing configuration, which minimizes radar signature beyond anything we've seen so far. What really sets sixth-generation fighters apart is their integration with autonomous systems. The F-47 can serve as a command node for collaborative combat aircraft, autonomous drones that extend the fighter's sensor range and weapons capacity. A single pilot could control several unmanned wingmen, multiplying combat effectiveness and reducing risk to human operators. The aircraft's adaptive cycle engines, potentially including the Pratt & Whitney XA100, allow switching between high-speed performance and fuel-efficient cruising. This flexibility enables sustained operations over vast distances, while still maintaining the speed needed for air combat. The engine's variable cycle capability optimizes performance for different mission phases. Advanced avionics systems incorporate artificial intelligence to manage sensor data, coordinate with autonomous platforms, and assist pilot decision-making. The F-47's cockpit represents a fundamental shift from traditional controls to AI-assisted interfaces that can process information much faster than human operators, while still keeping humans in charge of critical decisions. Soldier augmentation systems, the enhanced warrior. American soldiers are already using augmented reality systems that overlay digital information onto their field of view, allowing them to see enemy positions through walls and coordinate with teammates through shared digital displays. The Integrated Visual Augmentation System, or IVAS, represents the most advanced soldier enhancement technology ever deployed. IVAS combines Microsoft's HoloLens technology with military-specific capabilities to create a comprehensive situational awareness platform. Soldiers can see thermal imagery, night vision, and digital maps overlaid on their natural vision, while also receiving real-time intelligence updates and communicating with their unit. The system even integrates with vehicle sensors, so soldiers can see outside before dismounting into dangerous areas. The latest IVAS 1.2 variant addresses earlier reliability issues and introduces improved sensors, plus a more comfortable form factor. The system can attach to combat helmets with a hinged mechanism similar to traditional night vision goggles, allowing soldiers to raise and lower the display as needed. Enhanced low-light sensors also improve target identification in tough conditions. Beyond visual augmentation, the military is developing physical enhancement systems. The Soldier Assistive Bionic Exosuit for Resupply, or SABRE, reduces lower back strain during heavy lifting operations. Recent tests show that 90% of soldiers reported enhanced task performance when using the exosuit during field training, which really demonstrates practical benefits for logistics operations. Current soldier augmentation is focused on enhancing human capabilities, not replacing them. These systems amplify natural senses, improve physical performance, and provide information advantages, all while keeping human decision-making authority intact. The ultimate goal is to create more effective soldiers, not robotic replacements. Quantum computing for defense, the ultimate codebreaker. The Pentagon is, racing to develop quantum computers that could solve in just minutes what would take traditional computers thousands of years, while at the same time preparing defenses against adversaries who might achieve quantum supremacy first. The Defense Department's quantum initiatives, honestly, represent both the ultimate weapon and the ultimate vulnerability in future warfare. Quantum computers exploit quantum mechanical properties like superposition and entanglement to perform calculations that are just impossible for classical computers. A cryptographically relevant quantum computer could, in theory, break current encryption systems that protect military communications, financial networks, and classified information. This capability would, render most current cybersecurity measures obsolete almost overnight. The military's quantum research is focusing on three primary applications: quantum computing for complex problem-solving, quantum sensing for detecting previously undetectable threats, and quantum communications for unhackable information exchange. Quantum sensors could potentially detect stealth aircraft, submarines, and underground facilities with unprecedented precision. DARPA's Quantum Benchmarking Initiative aims to determine whether industrially useful quantum computers can be developed faster than current projections suggest. The program evaluates quantum computing companies to, basically, separate legitimate progress from marketing hype, while building verification capabilities to assess quantum claims. The Pentagon's quantum strategy emphasizes both offensive and defensive applications. While quantum computers could provide overwhelming advantages in intelligence analysis and cryptography, they also, threaten existing security systems. The military is developing post-quantum cryptography to protect against future quantum attacks, all while pursuing quantum advantages for American forces. AI-powered battlefield management, the digital commander. U.S. Marines in the Pacific are already using artificial intelligence chatbots to analyze surveillance data and identify threats, marking the beginning of AI's integration into real-time combat operations. This represents the second phase of military AI adoption, moving beyond simple automation to systems that can engage in human-like reasoning about complex battlefield situations. The Pentagon's Generative AI Task Force, led by the Chief Digital and Artificial Intelligence Office, is coordinating AI integration across all military services. Current applications include intelligent decision support systems that assist commanders in making tactical decisions, and aided target recognition systems that help identify enemy forces and equipment. Military AI systems are designed to augment human decision-making rather than replace it. The technology excels at processing vast amounts of sensor data, identifying patterns humans might miss, and providing recommendations based on comprehensive analysis. However, human operators retain ultimate authority over critical decisions, especially those involving weapons employment. Advanced AI applications include predictive maintenance systems that anticipate equipment failures, logistics, optimization algorithms that improve supply chain efficiency, and training simulations that adapt to individual soldier performance. These systems learn from experience and continuously improve their effectiveness through machine learning algorithms. The integration of AI with other emerging technologies creates synergistic effects. AI-powered systems can coordinate autonomous vehicles, optimize directed energy weapon targeting, and manage complex multi-domain operations. This convergence of technologies represents a fundamental transformation in how military operations are planned and executed. Advanced Electronic Warfare Systems, the Invisible Shield. The U.S. military is deploying electronic warfare systems that can jam enemy communications across entire regions while simultaneously protecting American forces from similar attacks. These systems represent a new generation of electromagnetic spectrum dominance that treats radio waves as both weapons and shields in modern warfare. Electronic warfare encompasses three primary areas: electronic attack systems that disrupt enemy electronics, electronic protection measures that defend friendly systems, and electronic support activities that gather intelligence through electromagnetic monitoring. Modern systems can operate across multiple frequency bands simultaneously while adapting to enemy countermeasures in real time. The Army's expeditionary cyber and electromagnetic warfare teams provide tactical electronic warfare capabilities directly to combat units. These teams can jam enemy communications, disrupt unmanned aerial vehicle operations, and protect friendly forces from electronic attacks. Their equipment includes portable jammers, signal intelligence systems, and cyber warfare tools. Advanced electronic warfare systems use artificial intelligence to identify and counter enemy electronic systems automatically. These systems can recognize enemy radar signatures, communication protocols, and electronic warfare techniques while adapting their countermeasures accordingly. The speed of electronic warfare requires automated responses that operate faster than human reaction times. The integration of electronic warfare with cyber operations creates new possibilities for disrupting enemy forces. Electronic attacks can disable enemy sensors while cyber operations manipulate the data those sensors collect. This combined approach can create false pictures of the battlefield while blinding enemy forces to actual American positions and movements. Space-based military assets, the ultimate high ground. The U.S. military is deploying satellite constellations that can track hypersonic missiles, provide global communications, and potentially engage targets from orbit, establishing space as the ultimate military domain. The Space Force's development of next-generation satellite systems represents a fundamental shift in how America projects power globally. Military space assets provide essential capabilities including GPS navigation, secure communications, intelligence gathering, and missile warning systems. Modern satellite constellations use distributed architectures that make them more resilient to attack while providing global coverage. These systems enable precision weapons, coordinate joint operations, and provide real-time intelligence to forces worldwide. The military is developing responsive space launch capabilities that can deploy satellites within hours of need. This rapid deployment capability ensures continued space-based support even if existing satellites are destroyed or disabled. Small satellites and CubeSat swarms provide redundant capabilities at lower cost than traditional large satellites. Space-based sensors can track threats that ground-based systems cannot detect. Satellites equipped with infrared sensors can identify missile launches anywhere on Earth within seconds, providing early warning of hypersonic weapons and ballistic missiles. Advanced space telescopes can monitor adversary activities and provide intelligence for military planning. The weaponization of space remains controversial, but the military is developing defensive capabilities to protect American satellites from attack. These systems include satellite-based interceptors, electronic warfare capabilities, and maneuvering satellites that can avoid hostile actions. The goal is maintaining American space superiority while deterring adversary space weapons. These 10 revolutionary technologies represent America's commitment to maintaining military superiority in an increasingly complex world. From hypersonic weapons that arrive without warning to quantum computers that could reshape cryptography forever, each innovation addresses specific challenges while creating new possibilities for future warfare. The convergence of these technologies will define military power for the next 50 years, ensuring American forces remain unmatched on tomorrow's battlefields. Which of these game-changing innovations impressed you most? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible military technology stories. Until next time, stay curious about the future.